Now here, let us see now the questions. Only that table will be used in our question. The question is here, find the principal value of the following function. Now here the questions are very much simple. Now the question is sine inverse 1 by under root 2. We have to find out the principal value of the following function. Now in the table we know that the range of inverse sine inverse x is what? Closed interval minus pi by 2 to pi by 2. It means when we will find out the principal value of this, the answer lies in the interval closed interval minus pi by 2 to pi by 2. Now let us see the questions. The sine inverse 1 by under root 2. It can be written as sine inverse. The 1 by under root 2 can be written as sine pi by 4. Now this value belongs to our range. Now here sine and sine inverse are two inverse operator. They will cancel each other. Just remember it. These two are known as what? Two inverse operators. So they will cancel each other. The answer is what? Pi by 4. Similarly, let us take another question. We have to find out the principal value of sine inverse minus 1 by 2. Now it can be written as sine inverse as it is. It can be written as minus sine pi by 6. Now sine pi by 6, it can again, our answer will be in this interval. Now here sine inverse, this can be written as sine of minus pi by 6 because we know that sine of minus theta equal to what? Minus sine theta. So therefore it can be written as sine of minus pi by 6. Again they will cancel each other. The answer is what? Minus pi by 6. We have to just here all the answer that we are finding the principal value of any inverse trigonometrical function that must lie within the range of that inverse trigonometrical function. Similarly, let us see another question. Cot inverse minus 1 by under root 3. Now here the domain of cot inverse is 0 to pi. Sorry, range of cot inverse is what? Open interval 0 to pi. Now this cot inverse minus 1 by under root 3, it can be written as minus cot pi by 3. Now it lies in what interval? 0 to pi. Now it is what? Negative. In this case we can take it like this. But in this case our range is what? 0 to pi. Now it is what? Negative. So there in the first quadrant code is positive, but in the second quadrant code is negative. So we can change the quadrant here. It can be written as cot inverse cot pi minus pi by 3 in the second quadrant. Now simplifying, we are getting here cot inverse cot 2 pi by 3. So simplifying, the answer is what? 2 pi by 3 belonging to what? Open interval 0 to pi. This is the principal value of this very inverse trigonometrical function. Similarly, let us take another question. Cos inverse minus under root 3 by 2. Again here the range of cos inverse is closed interval 0 to pi. It means our answer should be that very interval. Now again it can be written as cos inverse. It can be written as minus cos pi by 6. Again we have to shift into the second quadrant. It can be written as cos pi minus pi by 6. So it is what? Cos 5 pi by 6. So it is equal to 5 pi by 6 belonging to closed interval 0 to pi. Let us see the question again. It can be asked in 1 marks question. Our first exercise of inverse trigonometry unit only based upon the table. Now here the question is find the principal value of the following function. Now first I have taken sine inverse 1 by under root 2. 1 by under root 2 can be written as sine pi by 4. Then again this value lies in our range and they will cancel each other. So it is equal to pi by 4. Similarly, sine inverse minus 1 by 2. It can be written as sine inverse minus sine pi by 6. Now we can, this negative sign should be shifted like this, sine of minus pi by 6, because sine of minus theta equal to minus sine theta. And therefore it is what? Minus pi by 6 belonging to this very interval. In the case of cot inverse minus 1 by under root 3, it can be written as what? Minus cot pi by 3. Now here the range of cot inverse function is what? Open interval 0 to pi. It means we have to just simplify such that this value lies between what? 0 to pi. Now it can be shifted to the second quadrant because in the second quadrant cot is negative. It can be written as cot pi minus pi by 3. Simplifying, we are getting it is 2 pi by 3. Similarly, in the case of cos inverse minus under root 3 by 2, it is what? Minus cos pi by 6. Again, it can be shifted to second quadrant, cos pi minus pi by 6. So, it is what? Cos inverse cos 5 pi by 6. Simplifying, we are getting what? 5 pi by 6. Now, let us see the another question. Now, the question is here, evaluate sine of cos inverse 1 by 2. Now, here, in maximum inverse trigonometrical function, the solution of the question is starting just by putting the given inverse function equal to theta. Now here we have to evaluate this. Now we put cos inverse 1 by 2 equal to theta. This implies cos theta equal to 1 by 2 and it is what? Positive. Now if cos theta is 1 by 2, we can find out the sin theta, that is under root 1 minus cos square theta. We are taking the positive value because cos theta is here what? It is what? Its interval is what? 0 to pi. But it is positive, so it must lie in the first quadrant. And in first quadrant, sin theta is also positive. So therefore, the value of sin theta equal to under root 3 by 2. So therefore, putting this value of this, it can be written as here sin theta equal to under root 3. We suppose this is what? Theta. Now it is what? Sin theta. Sin theta is what? Under root 3 by 2. See the question again. In all the inverse trigonometrical function, you also care. Here is sine, so here should be sine. Here will be cos, so here will be cos. The both these function either outside the bracket or inside the bracket, they will be always the same. So now here sine cos inverse 1 by 2. Now we have to convert it into sine to just simplify it. Here is sine, so it must be sine. Here is cos, it must be cos. Here is tan, it must be tan. This you have to care. Now here we will generally inverse trigonometrical functions as just starting just by putting the given inverse trigonometrical function equal to theta. We can take cos inverse 1 by 2 equal to theta. Then cos theta is 1 by 2. It is a positive value. Now if cos theta is 1 by 2, sin theta is always sin theta also we have to take the positive value. So sin theta is what? Under root 3 by 2. So therefore putting this, it is equal to sin theta. And sin theta we are getting what? Under root 3 by 2. Let us take another question. Now we have to solve tan cos inverse 8 by 17. Now here is tan, so it should be tan. Now just what we are doing here, let again we are supposing this inverse equal to theta. This implies cos theta equal to 8 by 17. Now we have to convert this value in the terms of tan. Now cos theta is 8 by 17. We can take help of what? This right triangle. This suppose theta. Cos theta is 8 by 17. So this by using the Pythagoras theorem, it will be what? 15. So therefore tan theta is what? 15 by 8. Now again it is what? Tan theta. So answer will be what? Equal to 15 by 8. Let us see another question. We have to find out the value of tan inverse under root 3 minus cot inverse minus under root 3. Again the question is here, tan inverse under root 3 can be written as tan pi by 3 minus cot inverse minus under root 3 can be written as minus cot pi by 6. Now we know the range of inverse function is what? Tan inverse is what? Open interval minus pi by 2 to pi by 2 and this value lying in that. So therefore there is no need to change it. Now it is cot inverse minus cot pi by 6. Again the range of cot inverse is what? Open interval 0 to pi. It means this value must lie between what? 0 to pi. Now minus cot pi by 6 again shifting to the second quadrant. So it must lie within the range. So then we are simplifying. Earlier we have also done this question. Now it is what? Tan inverse tan pi by 3 minus cot inverse. It can be written as cot pi minus pi by 6. So it is what? Pi by 3. It is what? Pi minus pi by 6 is 5 pi by 6. Simplifying, we are getting the answer is what? Minus pi by 2. Now let me take one more question. Tan inverse 1 plus cos inverse minus 1 by 2. Now here tan inverse 1. 1 means the value of tan is 1 when tan is theta is pi by 4. This one can be written as tan pi by 4. It is a standard angle, and therefore cos inverse minus 1 by 2 can be written as minus cos pi by 3. Again its range is what? Close interval 0 to pi. So interval should be changed. It will remain as it is. Cos inverse cos pi minus pi by 3. So it is what? 2 pi by 3. So it is what? Simplifying pi by 4 plus 2 pi by 3, and by taking the LCM, solving it, it is equal to 11 pi by 12. Let me take one more question. Now again we have to find out sine pi by 3 minus sine inverse minus 1 by 2. Let us see sine pi by 3 as it is. Again sine inverse, this minus 1 by 2 can be written as minus sine pi by 6. Now the range of sine inverse function is closed interval minus pi by 2 to pi by 2. In every question you can easily write down the range of the whichever inverse trigonometrical function we are considering in the question. You can easily write down the range of that very inverse trigonometrical function. Now here sine pi by 3 as it is minus sine inverse. Again it can be written as sine of minus theta is minus sine theta. It can be written as sine minus pi by 6 to get the required range. So now here it is again sine pi by 3. Now they will be cancelled each other. So therefore pi by 3 plus minus minus plus pi by 6. So it is what? Sine pi by 2. That is equal to 1. This is the simple way to do the question. All the questions are based upon what? Only the range of inverse trigonometrical function that is given in the table. Now here let us see some more result on inverse trigonometrical function. These results are in your book are given after exercise 2.1. But sometimes these results are making our question of exercise 2.1 very much simple when we are using these results. And it is also one of the important result of inverse trigonometrical function. Again I have written here CTM is considered to have. The results are very much simple. Sin inverse x plus cos inverse x equal to pi by 2. Tan inverse x plus cot inverse x equal to pi by 2. Secant inverse x plus cosecant inverse x equal to pi by 2. Here because the domain of sine and cos is what? X belongs to close interval minus 1 to 1. Similarly for this x belongs to R because tan and cot x can be defined for every value of x. Now here secant inverse x plus cosecant inverse x equal to pi by 2. X belongs to R minus open interval minus 1 to 1. Only we have to just learn these results. Sin inverse x plus cos inverse x pi by 2. Tan inverse x plus cot inverse x equal to pi by 2. Secant inverse x plus cosecant inverse x equal to pi by 2. Now let us use this question in our let us use these results in our question. The questions are here. Tan inverse 1 plus cos inverse minus 1 by 2 plus sin inverse minus 1 by 2. Now tan inverse 1 can be written as tan pi by 4. Now we have seen the result. Cos inverse x plus sin inverse x is what? Pi by 2, and the value of x is minus 1 by 2 lying in this interval. So we can apply this result. And moreover questions are framed like this. We can easily apply the result. Now it can be written as tan inverse 1 can be written as tan pi by 4. Now we are using this result. It can be the sum of this is sin inverse x plus cos inverse x equal to, we can write down pi by 2. Then simplifying it is what? Pi by 4 plus pi by 2. Answer is what? 3 pi by 4. It makes our question easier when we have used this result. Similarly, let us see the another question. Cos inverse 1 by 2 plus 2 sin inverse 1 by 2. Now it can be written as cos inverse 1 by 2. Now 2 sin inverse 1 by 2 can be written as sin inverse 1 by 2 plus sin inverse 1 by 2. Again the sum of these two, cos inverse x plus sin inverse x is what? Pi by 2. And this sin inverse 1 by 2, it can be written as sin inverse 1 by 2 is what? Sin pi by 6. Then simplifying we are getting what? Pi by 2 plus pi by 6 equal to 2 pi by 3. See again here, these are the results that are making our question of exercise 2.1 easier. So I have introduced this result earlier here. Now the first is sin inverse x plus cos inverse x equal to pi by 2. This value of x should be the same when we have to apply the result. Tan inverse x plus cot inverse x equal to pi by 2. Secant inverse x plus cosecant inverse x equal to pi by 2. Let us see the application of this result. Tan inverse 1 plus cos inverse minus 1 by 2 plus sin inverse minus 1 by 2. We can write down the sum of this is what? Cos inverse x plus sin inverse x is what? Pi by 2. This we can solve. Tan inverse 1 can be written as tan pi by 4. Then simplifying we are getting here pi by 4 plus pi by 2. Answer is what? 3 pi by 4. Similarly in this question, cos inverse 1 by 2 plus 2 sin inverse 1 by 2. Just writing this angle 2 times and then using again cos inverse x plus sin inverse x is equal to pi by 2, and this can be solved. Sin inverse 1 by 2 it sin pi by 4. Again answer is what? 3 pi by 4. Otherwise when you are doing by using the table and finding all the principal value of each and every inverse trigonometrical function, the solution may be lengthy, but when we have used this result our question becomes easier. So this is all about today. Only what we have learned what is inverse trigonometrical function, and the main we have to learn the table in which all the domain and the range of inverse trigonometrical functions are given, and maximum use of that table is there in this very unit. And from this exercise the question of 1 marks can be easily asked in the exam. And tomorrow we should continue this topic. This is all about today. Have a nice day. Thank you.